Hello and welcome back to another video in my series on how to program PLCs. With this video, I'm showing a pretty cool project. We were assigned this in our final year manufacturing design class. Essentially, the goal is we need to design a sorting conveyor system that sorts four types of parts into different piles. Uh, what I kind of had in mind for this project was to save some costs with a system that only uses a single piston and a single solenoid valve. So basically, the goal is to reduce these pistons down as much as possible. You can see we only have one active here. Uh, Pistons and their associated control valves, the solenoid valves, are pretty expensive and would have made up the bulk of our project budget. So by getting this down to a single piston, we save a lot in the design budget. What we have going on here is we have a parts emitter, which is just simulated by the parts emitter in Factory IO, a vision sensor here, which is going to read what type of part has landed onto the conveyor belt. This will be programmed into a camera and read by an Arduino. The PLC programming will not be done in CodeSys. It will be done in the Arduino PLC program. They have something like that I'm going to have to look into. Haven't done any Arduino PLC yet myself, but that'll be fun. So the part drops down on the conveyor. It's identified by the vision sensor, and these three locations over here, you see we have green part, metallic part, and blue part. And then over here we have these blue unmachined parts. So these parts don't have any features on them, so we'll call those the defects. So we have a four-way sorting system by using a single piston, by using the conveyor as another option to sort the parts. If it is a scrap piece, it can be immediately ejected off of the left side of the conveyor here into the scrap pile. And if it is a good piece, we have three options for it to go. For this green part here, let's pause real quick. The piston pre-extends once it determines that it is a green part. In our case, we're dealing with squares, triangles, circles, and the defect part is an octagon. But we'll imagine the green part is a square, we'll say. The once it's identified by the camera that this part is green or it's a square, whatever you want to think about it as, the piston pre-extends. And then we have a scraper blade that is going to pull the part off of the back of the conveyor belt to drop into whatever collecting bucket we have on that side of the conveyor. There's some mismatches between the available assets in Factory IO to what we're actually going to be designing. A couple problems here. You can see these blue pieces are not falling off the conveyor belt. We are sizing our conveyor belt and our pistons accordingly so that it does push them all the way off. I just can't resize anything in Factory IO. So that was one limitation. Had this bar here that I've definitely put in the wrong spot. It's not needed. We can just delete that. So we have a metal part coming out. The camera has identified it that it is a metal part, and it's going to store the value of that metal part. Let's say that these are the triangles. It's going to store the value that this is a triangle, and it knows that the sorting bin is all the way off the end of the conveyor. Being that it is all the way off the end of the conveyor, and we don't need to actually time it or line it up with the piston here, it doubles the speed. So we can push these metal parts off the end of the conveyor belt at a higher speed because we don't actually need to hit them with the piston. This is going to save some time in the cycle because they do travel the furthest distance, these metal parts. They're going to have to go about twice as far as the green or the blue ones. Let's unpause this, and we see that sorts off to the end. I could probably speed up that one too, eh? We can speed up the parts coming off the back. So this is a scrap part. This has not been quote unquote machined, so it's identified as defective and thrown into the scrap pile. We have another gray part coming out here, and that gray part is going to be accelerated twice as fast off the end of the conveyor belt into the good bin for, I think we said triangles. We have a green part. It's going to pre-extend, and then it's going to pull that part off the back of the conveyor belt, sorting that into its appropriate bin. Again, it's hitting this so late on the paddle because I have to deal with this little gap here. If you actually grab it in the middle, it just jams up the piston, which again, we're sizing our materials to not have that happen. So kind of just a little workaround I had to do for this equivalent machine. That's going to pull that off the back. We have a blue part. It's going to push it. Now, in the actual machine, this part would need to fall off the conveyor belt. We're sizing our things appropriately. This is just a proof of concept, the demonstration of the logic, and that we can get these that theoretically we can get these sensors to work in real life. It's going to take some magic from the camera programming team. I'm looking forward to seeing what goes into programming. Would this classify as machine vision? I mean, it seems pretty rudimentary, but that is going to be cool. I'm looking forward to that. And here we go. It's going to pull that part off the back. Metal part gets sorted faster, so it doesn't take as long to get to the end of the belt. Yeah, you see this blue part here is just kind of hanging out. That would normally just be knocked off the end. So just one of the limitations of this simulation. Give it a helping hand. And that's about that. So that is what the machine looks like. Let's take a look at the actual programming that went into it. So what we have here is camera, which is a variable that I've set. It is a d-int. I spent a long time trying to figure out why my ints weren't passing to the camera, and that is because the camera is d-int, only positive integers. So you can't have negative values be passed into it. That's why it wasn't working. So you see we have camera value here. So the camera value is actually what the camera sees. And then so if that's not equal to 0, 0 is staring at the conveyor belt. If that's not equal to 0, it's going to pass that value to camera value. And then camera value gets stored until the actual sorting process is resolved. So that keeps that value stored for us, updating only when the camera sees something new. So yeah, we can see that the camera moves, or the camera value 9 is moved, 3 is moved, and then we have our encoders on the conveyor belt. So with the encoder, that is triggering every however many degrees, and that's how we know how far the conveyor belt has traveled. So we have encoder A here. There were 2 encoders. I'm running them all off A. And then if camera value is equal to 0, it's going to reset the count. So the camera value so far can't be set to 0 from anything up here. So the end of each sorting process involves moving some variables back to their default state to start the next process of sorting. With the camera value being equal to 1 here, that's going to be our blue unmachined. So this is our scrap. So we just multiply the conveyor speed. So I've made a variable here so I can see how fast and how slow I can get the conveyor speed running. I just said that we could probably speed this up. So actually, why don't we go ahead and do this now? What I can do here is take this constant. This is just meant to flip the direction of the conveyor, but we're going to just multiply that by 2, and we'll speed up the scrapping process as well, because that also doesn't need to touch the piston. We can actually see if this works. See, we got jammed up here. Limitation of the software. We can't change the sizes of these parts. I want to see a scrap one. Come on, let's see a scrap one. It's randomly generated from the emitter, so just as well as we're going to have randomly strung together parts, this is also random. We are getting no scrap. This is incredibly unlucky. 1 in 4 chance. 1 in 4 chance. Let's go back to the stats book and see what the odds are of this. There we go, and that throws that part off much quicker. Okay, cool. We fixed that. So camera 1, if camera value equals 1, it is going to flip the preset conveyor speed. I can set the conveyor speed to whatever I want over here. 1 seems to be working fine. So that's going to double the speed, knock it off the back. When the encoder reaches 6 ticks, it is going to move the camera value to 0, thus restarting the process, and it's going to move the conveyor value to 0. Because if you don't reset the conveyor value at the end of each sorting process, it'll give you some weird. It'll still be running. It'll pull back a part that was supposed to be going forward, or it'll push forward a part that was supposed to be going backwards. So it's best to just control the system and stop that conveyor belt between each part. So if camera equals 3, we'll say that's our our square. Sure, this is the square sorting line. The conveyor speed is passed to the conveyor. That's the variable, so I can tune this, but it's going to pass it to the actual conveyor. And then once the encoder is greater than or equal to, or is greater than 8, it is going to activate the pusher. So once the encoder value is greater than 8, it's going to activate the pusher. That is going to reset once the pusher reaches its front limit. So it's fully extended limit. That's what this line is doing here. And we go a little bit further. These lines were kind of long. It's going to reset the camera, and it's going to reset the conveyor, and then it's going to retract the pusher. So we go down. We're doing camera value 6. These are our green parts. This is triangle. Did I do triangle yet? As soon as 6 is red, it's going to activate the pusher so that it can be pre-extended for when the part moves into that area. The conveyor speed is set to 1 because we want the part to move forward. And then the encoder goes 11 ticks. So these all have different values. Probably we will be able to use the same value for both the forward and backwards motions on the actual part, but because this guy gets jammed up a little bit in factory IO, we have to make sure it tilts off the back end to clear the pusher. So then once the pusher is, or once the part is in position for the pusher, it will pull the pusher back, and then thus knocking the part off the back of the machine. Once the pusher has reached its limit, we have limit switches available to us to detect these limits as well, which is nice. So once the pusher back limit has been hit, it's going to reset the camera and reset the conveyor to 0. Our third case, this is the metallic part going off the end. If camera equals 9, it's going to store that, and then we are going to get 2 times the conveyor speed. We want to quickly get that thing off the end of the conveyor. I mean, I really could use a separate variable for all 4 of these, or just a couple of them if I wanted to, but this seemed most straightforward. 2 times the conveyor speed, and then the encoder's going the furthest distance here, 20 ticks. I'm not exactly sure what the ticks correspond to distance-wise. I don't think there's a way for me to measure that in the factory IO environment. But then it's going to move the values back to 0, and we're ready to start the next sorting process. We have some buttons, some physical controls that can be wired in, but I think if you watched any of the previous 4 videos, you know that probably won't be a problem for me to set up. That's kind of an afterthought. I just wanted to test this logic here, make sure that this works, and I can incorporate all the usual features in at the end. Get this guy a hand. That's it. That's the project. Single pusher, 4 location sorting device with a vision sensor, aka it's going to be a little Arduino camera sort of thing. it's going to be very cool. Very excited to get into this project. This is probably the most excited I've been for a project in my whole degree. It's very cool. I'm very excited for this one. But anyways, yeah, that's it. Thank you very much. Bye now.